All right. So, like what we completed till last time is that we have a working test case or bunch of test cases for grep, where we have grep from file and also we can grep from standard input. So we refactored in the last discussion. We refactored our code to evolve to a reader interface instead of a file or a standard in. So this is much more generic. What we want to do next is see if there is an opportunity for us to refactor the code and then move on to the next story. Yeah. So what I see, like there is some opportunity for refactoring that I see, or formatting, I would say. Like I generally don't like personally, my preference would be to not have a lot of new lines unnecessarily. So new line should be used for a purpose of breaking the flow into some parts. Again, there is this squiggly line, so I'll just fix that using IntelliJ. So this is one other thing. Then we have the scanner and error is one part, so I'll group them together like this. And search compilation and search is here. So the search string is
that line 16 might cause the test cases to fail. Can you run the test one?
Yeah, let me run the test case. Okay, yeah, so we will revert this. Why? Okay, it's a new empty.
Can probably I just faced this 5 minutes ago in my another assignment that I was doing. So what you can do is go to main.test. Can you open it side by side? Yes. Can you go to the top where we have written the expected? It failed for which one?
We run this, it fails. Okay, now it passes. No, this is the this. So it fall for not existing match.
Not. So what we can do is declare a variable called, let's say, nil slice on the top.
Yeah, so is it because of deep equals in slice?
No, it's because here this is a nil slice, right? Line 17 of main.go. That is a nil slice. But what we have given in our test, go to the top, please.
This test.
It is actually a memory allocated string.
Yeah.
With nothing. So we are comparing those two things, which is throwing an error. Instead of that, what we can do is we can create a variable in line 39 as, let's say, var nil slice. Same syntax as line 17 in main.go.
Yeah.
And assign that in line 52.
Correct.
Yes, you can try this now.
Yeah, this is because of the allocation. Okay, yeah, let's use this then, so that we can also get rid of this new line. So the test case are still passing. What we can do, is there anything to refactor in the main test? Let's look at that real quick. Okay, check the formatting is okay. Test cases are fine. Okay, can again delete some lines here. Don't need the trading lines and whatnot. All right, so I'll make a small commit. I've also cleaned up the README a bit to make it more
Okay.
fit in the same.
We can also remove the main core of the problem to another function, and then maybe this line 31. No, not 31. Sorry. This 25 should probably refactor it out of this method.
We will have to pass the text and the. What will be the purpose of that? I'm just wondering.
Okay. I just wanted to use, acha, since we have already made this grep common for
Correct. Now it is common for both. So I think that's the reason I feel it is okay to have it here.
then it's fine. I thought it was
Because
in
otherwise we'll have to pass the entire, like all the variables like match lines, the scanner, and a bunch of other variables. So it will be more work than the value
yes,
you
yes,
get.
yes.
So
Agreed.
just say reformatting or here. Like,
I think this looks fine.
so this is what I'll commit. So now moving on to the next test case. What we have is we are done up to this point. We haven't implemented I mean we didn't implement the CLI part of it, but that's okay. We'll directly implement the right output to a file instead of standard output now. That's the next story, right? So in that story, what we have is, let's again start with test cases. The fact is now this is going to be super simple because whatever we get out of this function, we just have to write it to a file and then read from the file.
Right.
So as a story, because of our design, because of the way we have designed the interfaces, this story becomes a cakewalk almost, where we don't have to do anything. We literally just have to write the output that we get from this function to any file that we want. And in the test case, we can read the file as it is and check that whatever where the match is. So the functionality in the code doesn't change, only the periphery changes.
Right.
So I'm almost tempted to say that we can go ahead and skip this exercise completely or skip this story completely, because it is not really adding any new value to the program. We can do it if you want to, but it's going to be a very dumb simple story.
Right. Right.
So instead what we could do is we could work on this next story, which is a bigger one, and try to come up with a design and brainstorm around this in this call.
Recursively.
Yeah, so the next step in the grep is to be able to recursively search files in a given directory. So far we have been operating on a single file or a single reader, which can read from a readers typically corresponds to a file most likely, or some sort of a socket identifier. So in this case now we are going to have to we are going to be given a directory or a single file. It could be any of that. So if it's a single file, then we just search and grep within that file and we're done. If it is if it's a directory, then we have to recursively grep the entire directory. So not only we have to traverse the top level files in that directory, but also recursively traverse all the subdirectories and all the files in those subdirectories, if there are any.
Okay.
Another challenge here is that we have to preserve the order of sorts. So what does that mean? It means there are multiple files. Let's say this test1.txt and test2.txt. This is the format, let's say, and each of these files have a line that matches, and we are trying to grep for a word called test. So we can see that this test word is present in 3 files, but the output from this single file is all in like together. Like we don't have this as output. So the output shouldn't be interleaved. It has to be one file should produce its complete output.
And so what is the expectation on the output being printed to the command line? Sorry, to the terminal. Should it be that once you have traversed all, then you should print it one by one, or if any data is available, then print it?
Right. So I think the program doesn't mention that. So we can use that to our advantage, or we can in a real project we would actually go back to the person who created the requirement and suggest them what is the easier approach, what would we recommend, what is easier for us to do, or even clarify what is the expected from them. Like, do we have to wait for the entire thing to complete, or do we print it as we go? A sane approach or a good assumption would be to print as we go, because it's almost like whatever files we have read, we don't have to accumulate the entire output in memory. We can just print and forget it.
Okay.
Right? So that would be a like from a user point of view also, if I were to search and if I find that match in the first file and I'm happy with that match, I could also control C the program and stop the program. So that's how grep also behaves, that it does not wait for the entire thing to complete. It prints things as they appear in the files that it tries to grep into.
Right.
So any thoughts from anyone on how we can like what are the ways in which we can do this, and we have to do this again via test driven development, right? That's the thought process. So what is the kind of test we can write for this function, and how will it even evolve? So let me again open this up on this side on the right, and look at the test case on the left.
Yeah. Let us write the test name first.
Yeah, so let's start with the
test recursive grep.
okay, that seems like a test name. Testing.t, and yeah, so again we always start with given, when, and then. So with this we will focus on the when part first. The when will be, it will be a, I'm guessing it will be a grep kind of function, which for now we are assuming takes a dir,
Right.
right? And it also takes the search string as a string,
Correct.
something like that. So it takes these two inputs. So let me create, this is like okay, some string that I have, and dir is also going to be some string variable for now. That is what I'm considering. We will evaluate the implementation for this.
Okay, and what should be the return type? It should be a list, a slice of strings.
So let me actually write a func here itself so that it's easier for us to call, and I'll call it here. Yeah, so we have a directory that will be a string and search string will be a string, and the output will then be
A slice of strings.
so if we have a slice of string as an output, how
Like if we print like one by one, then I think we can only print the slice. That's the string only. Like if we want to print the output one by one, like if like there are three subfolder and first string is matched on the first folder, then it will print. Then it will go to the second folder.
correct, right? So there are one way is if we were to do it in a way where we print everything at once, then it could be a two-dimensional array of sorts, right? That could be the
Like if we want to print one by one, then I think we can print strings only. Or if like if the output will be printed like
so what I'm thinking is like it has to be a bit more than a slice of string. The reason
A
is,
map.
yeah, because so there are two ways in which we can do this. Something like this is what I'm thinking as an output. Okay, one is, let's say we have a directory structure such as let me actually write it in this way. Yeah, we have a directory structure which is test1.txt and some dir slash test2.txt. There's only two files.
Okay.
Yeah, and each of them contain the word that we want. What we would like is the output to be, if we look at the, okay, we can take the same structure. The output is, there is a file name and a colon is printed and the actual line that is matching is printed. So this is almost like a prefix for which with the relative path of the file.
Right.
That is what we need. And essentially this means that we need all the lines from one file in some way. So if I were to take a naive approach, I'm thinking this is going to be either a like a map, right? A map of uh,
Strings and strings.
strings and slice of strings, something like that.
Yes, yes.
So what I'm thinking is this, that it's a map where the key in the map is file name, and the value in the map is uh, lines matching or matching lines in the file.
Right.
So and it's going to be a map of these, so that there will be multiple files, and for each file there will be a value which is a list of strings or a slice of strings essentially. This is one way to do it. If we did it that way, and if we return this data type here, then this also means that what we spoke earlier, which is the fact that we want data to be printed as it appears, that will not happen, because this function will return only when the map is fully populated.
Right.
So that's one side effect of that, having this kind of design. So we have to almost think what is the way in which we want to design this. With a test driven development approach, I think because we're expecting the entire output, we will end up having to create a function like with a map design, with a map return type. Almost we'll be forced to do it that way, because in test I don't think we can get a streaming verification. Right?
Yeah, that's what I was thinking. And even if we try to get a streaming in form of channels, then how can we guarantee this order?
Correct. So that is another way we could do. We haven't talked about channels and this part, but that would be a way. So this is one way where, so let's say we name this as approach 1, right, which is all computation together, like as in at once, or only when the things is complete, only then it returns the value. The other approach is going to be something like streaming computation. And streaming computation, we will have we will have to use a synchronization mechanism and a channel of sorts to return the values. So the return type from this function will be a channel where we can read from. So it is going to be a channel of readable string. So it will be a this kind of channel. This kind of channel, readable channel of strings of sort.
What if we use the channel of the same map that we have in line 132?
Yes, that makes sense. So we use a channel which returns a
as soon as one file has been grabbed, we'll have the data of one file in.
yeah, so that is what one way is to do it. Yeah, so what we need to figure out is what is a unit of granularity for us, right? So if you look at the output, it is safe to assume or safe to infer from this that we could create a Goroutine for each file to
Yes.
read and grab the contents of each of the files.
Yes.
Right, so the file becomes abstraction and our unit of computation and unit of parallelization of sorts.
Correct.
Where if there are like million files, a million Goroutines will be created, and each of them will operate independently of one another. They will create their own data. They will try to add this data to this channel, or they will return a channel that where we can read from.
Yes.
So if this is a syntax, then we can get the entire, like it's up to us, we can get a channel of so I'm almost thinking within a Goroutine, do we want streaming or do we want full output? Because it's channel, so we can also do streaming here if we want to. Ultimately, it doesn't matter when we push the data into the channel. That time in the test case, we can read the data from the channel, I guess. What I mean by that is, let's say there is one Goroutine here, which is reading this file, the test1.txt. As soon as it finds a match, does it return that match in the channel, or does it wait for all the matches to be complete and then return, then add them together in the channel?
If
So
it returns as soon as it gets one hit, then how to maintain the order? Because the other
file will be read in the order.
See, two Goroutines are reading test1.text and test2.text. One gets, let's say that Goroutine 1 gets a hit, it will send it to the channel, we print it out, and then after that the second Goroutine sends a hit to the same channel.
Yeah, so correct. So what I get what you mean. So the question, like the thing that we need to figure out is, what is the shared state between, like, is this, if it's a channel and every function is going to return a new channel to us, then it's almost like we'll have another function which will be a wrapper function on top of this, right? Yeah, or a fan in, as you said. Like these are all the channels that will feed into a final channel from which we can run and grep. Or how do I what we could do is, for now we can say that to simplify things, we can read one file in a Goroutine, read the entire contents, do the matching, and return a slice of, just like we preserve the existing functionality basically.
Yes.
We return the slice of string as a return type, so we can reuse this code. So this is a Goroutine. This function can run in a Goroutine, and it is capable of reading a file and returning the matchings from that file. Now all of them are already in order. So instead of returning a channel of strings, we can return a channel of slice of strings. And every time we read a slice, complete slice, which means we are reading these two lines in one go and this one line in the next go. That way we can just pop the data out of the channel and print that as it is.
So if you just send us channel of slice of strings, then how do you ascertain from which file you have got these strings, these matches?
So in the output, we can append a file name like this.
Yes.
That is one way, hacky way, I guess. Other way is to,
what if we
map
and a map,
yeah,
on the channel?
So it's going to be a channel of,
so you won't need, I think, multiple channels. Each Goroutine will share the same channel.
yes, so each coroutine will share the, so that's almost the input that we'll have to pass to this grep function, a channel that will have to be passed.
Yes.
Where this coroutine will write, and the test case or the other program will just read from this coroutine, this channel.
Yes, maybe we can create an adapter on top of grep, like recursive grep, and there we can pass the channel and then call grep from inside recursive grep.
Correct. Okay. Yeah. So if we look at the data type, I'm not sure whether others are following. What will be the data type of the grep? Let's write that down then. So it will have to have a channel. Right? So a channel of actually, let me write down the function signature here. So it will be a
chan of map square brackets, string.
So string, and
no, the second one is not required. The second, just string.
No, map contains some.
After the second square bracket, you can write string, just string. Yes.
Okay, so this is a map where the first string is the key of the file,
Yes,
and this string is,
value.
yeah, but this string can't be a single value. Like for a particular file, we will have
Slice of right.
many values, right? So it will be this, right?
Right, correct.
Yeah.
Yeah, but so now do we really need a map, because this will always contain so I'm not sure whether Go has a concept of a tuple. Tuple is basically two things, right? For example, this is a tuple. It
Right.
contains two things, right?
Right.
One is
I
the
don't
Like
think
one,
so. Yeah, Suraj.
yeah, one with the other kind of thing, right? So
so just two heterogeneous data types put together as a tuple. So
yeah,
if we have that, we could probably use that instead of creating a map, because this map will always contain only one key.
No, if of
um,
them are sharing the same channel, then each Goroutine will write on the same channel with different key, which will be the different file name.
Yeah.
Did you get my point?
Yeah, I get it. Thinking how.
Then we can range on that map, and as soon as, even if one entry is there, you print it out, which will correspond to one complete search of the whole file, of a single file.
Correct. So this is the Go routine that. So this is the channel where the things will be written to ultimately.
Yes, there's no need of a fan in according
There
to
is no
this.
need of a fan if we design it this way.
Yes.
And what is this function going to return? It is actually, I mean, we are passing the channel, which is a shared state. So we can just range over the channel over here and get the values.
Yes.
So almost like this becomes a shared state by communicating
Right.
paradigm. How do we handle errors if there are any? Something like that. And what all are the errors can be?
Errors could be directory doesn't exist.
Directory will exist because the top level directory doesn't exist. That could be, that is easy to guess. I'm guessing these errors will become more prominent, like not in a file descriptors or permission errors, or or just file not readable, or more like permission error kind of things will become more.
Can we have another channel for errors, because we can't send back anything from the Goroutines?
Correct. So we will have to have another error as a channel for this will be a channel of what errors, but then how will we know which error is corresponding to which file, or do we need to know?
We should know.
so that depends on what we want the descriptor to include, right? So
Correct.
do we
So
want the file name and or the file location that it tried to open and then it failed to do so? So something like that. So I think
Probably again.
R co so we can either return R itself, that we like directory itself that we got, like could not open this, something like that.
so the idea is that there are multiple errors and multiple outputs, which is what we're trying to capture. And there is almost like one-to-one mapping, like it's either or, like either you will get an error for a file, or you will get a map. That map may or may not have any values, meaning that like it could be a map of file name with an empty string array, indicating that there is no match in the file. So in that case, we can ignore and don't print it onto the console. Or the other way is there will be an error for a particular file. So it's almost like a either or kind of case here.
Right.
Yeah. Actually, we don't have to check, right? uh, what error we would expect, we could just call the grep function inside it. Are we still doing the like, are we calling grep inside this new function
Yeah,
that
our
we're writing?
plan is
Or
to reuse this function if possible, as much as possible. So this is what we see is this is a function that will be called in a Goroutine. So let's again, we are doing some thought experiments, so we can do that. So let's say if you call this function as a in a Goroutine, what will happen is that it is going to return. Um, yeah, it can't return. We'll have to modify this function to pass a uh, channel to it, right, where we can read from.
The function that you have written in main test, if you could rename that to recursive grep.
Okay. Yeah.
Yeah. And then maybe this is the Goroutine that will run, and from inside this Goroutine we can call this function grep. So we won't need to change any method signature for the grep function.
Correct. So from here we will call what you're saying is we will call grep. We'll pass the reader, which is whatever like directory or.
We really said write the file path.
So we'll say go this and then yeah, whatever is the file path.
No, not go to this. Go should be
Yeah.
written.
Yeah,
mean,
I think
120.
what Mohit is trying to do is recursive grep here is the worker, so it won't have any of the.
Oh, so
Go.
this is okay. So I thought this is the okay. This is the actual inner function then.
Yeah.
It's actually grepping and grepping the things.
Yes.
From a top-down approach, what would be a function which can orchestrate the recursive grep? Trying to think that right now. So this is a function that is going to recursively grep. Which function is actually going to call this function?
Okay.
And how will the behavior be for that? Trying to think that way.
If we want to use this grep function from main.go, then again another method is to be made, which is on top of this. That
One
would call.
other way I'm thinking is now this becomes a bit too much of a problem to chew at once. So this is where what I've seen work better in this case is some small POCs where we actually write the implementation to figure out what works, how it works, because we don't have that full clarity in our head, even if we go top down, because it is very difficult to identify the exact interfaces right away, right? Like we were able to identify grep function interface or signature easily. It is difficult to identify this kind of signature easily right now. So one way is to try out something in the code and see how we will piece together. So more like going bottom up in this case. And one bottom up is we already have a function that we can reuse. So this becomes a Lego block that we already have. We just have to figure out how and if we can use this with no or little modification in the overall scheme of things. Does that make sense?
Yes.
So and the other is we will also have to figure out a way to walk through the directory, right? So Go has I think file path dot walk is the function. So we will again be restricted by how this works, or we will probably want to use this. So what is the difference between walk and rooted at root? Okay, yeah, so we can either use walk directory or walk. Not sure what's the okay, yeah. So walk directory is what we can use most likely, and here this will mean that we pass the directory as a string. and then we write a func which takes this path and what is function directory and error. So we'll almost, yeah, this is another. So I guess this is a function which becomes like a orchestrator function, right? Because this function is responsible for supplying the directories or supplying the files
Yeah. Yeah.
to this
So
grep
inside
function.
this, we should be calling grep. Yeah.
Yeah. So this is a very classical like data engineering, or like I would say ETL, or like data pipeline kind of problem, Unix pipeline kind of problem, if you think about it, right? What I mean by that is we have a function that produces a list of strings, or like a string one at a time. Yeah, each string in that is going to be either a file or a directory. Right, so what this file path.walk does is it walks this directory, it produces a path. Like imagine this current directory. When I did a file path.walk on this directory, it will produce like 1, 2, 3, 4, 5, 6, 7 files, and it will call this walk func 7 times. One for in whichever order, like once it will call it for .gitignore, other it will call it for go mod license main.go, like that. And if there are any subdirectories, it will call it for that as well. We don't know whether this is depth first or breadth first. We can probably find out, but I guess it doesn't matter that much to us, as long as it creates, it calls it recursively. Then this D is nothing but directory entry. What does that mean? Yeah, it gives you info about what does this do, and if there is any error in reading or figuring out and doing the walking. So almost what I'm thinking is this function is producing a string one at a time, which is the path, and for every path, or every, or like produces a file almost, I'll say.
Yes.
Right, instead of directory, because if it's directory, we can again recursively traverse it and get the file. So ultimately it's almost like this. How do I, in functional programming terms, I'll say a directory, or let me write it this way: directory dir results in a list of files. Yeah, a file is just a string with the path. Okay, and what we will have to do is ultimately, as this function does these things and produces the file, we will flatten all of them together, and we'll finally imagine get a slice of strings where each string is a file
Yeah.
that we need to grep. We will obviously ignore all the directories here because can't grep into directories anyway. So what we are looking for is almost like find all the files in a given directory.
Right.
Only files, ignore the directories. So if this dir entry is going to be used here in this function, if it is directory, then we'll skip this. We'll not add it to the slice of strings. Only if it's a file, then we'll add it to that slice of string. And ultimately, this function or some function, after we do the walking, it is going to give us a giant slice of strings. For now, again, I'm considering non-streaming fashion. I'm considering all of it in one go. That means if we run this on root directory, it is going to take a while for it to actually get all the file names, and is going to then dump a 100,000 lines of like 100,000 line array string slices back at us. That is one bad thing about it. We can also try to make it streaming later if you want to, by again adding a channel and go routine and stuff like that here. For now, if you want to keep things simple to proceed, we can do it this way. So let's say we have this some function which does this, which given a directory, it gives us all the files in that directory, only files. Then we already have a function which can grep in a single file using a reader and return the output to us.
Okay, what if inside the walk directory func, we start a go routine if it is not a directory? The
Correct.
go
That
routine is supposed to do grep.
correct. That also works. So instead of getting this back for every string or for every file, we just start a go routine. Yeah, that also works. Yeah. So
Also, if we abstract the walk directory function to a different function, and we call it somewhere inside recursive grep, if the directory entry is true, like D is true inside the first directory, walk directory, we can call the other function so that we can traverse inside the subdirectory inside the path that was originally given.
yeah, so I'm guessing this walk directory does the walking recursively.
Yes.
So we don't have to actually call this recursively. So
I'm sure about walk, but I'm not sure about this one. In case of walk only, you had to check if it is a directory or not. Otherwise, rest of the things it takes care of.
yeah, so this is where we can do a POC on walk. Yeah, I also know about walk, not sure about walk directory. As per walk, this documentation, it says that walk is less efficient than walk directory, which is introduced in Go, which avoids calling this. So I'm guessing they want us to call like walk directory instead of just walk. So we do a file.walk and we say current directory, and if it is a directory and is to be skipped, then we skip it. Otherwise, we visited the file, we just write the file. So this is the part where we can start the go routine for
Correct.
grepping by passing a common channel that we can instantiate the channel over here or in like in this function outside before we call the file.walk. And that is a channel that we pass to the go routine, and that is where the go routine keep on adding stuff.
Right. Let us try with walk for now. If everything works fine, we can try
Yeah.
replacing walk with walk dir. Then
Correct. Yeah, I'm also keeping a check on the time. I don't think we'll be able to write a function and actually implementation right now. We'll try to conclude this just brainstorming in some way where we figure out the details. So we might have to comment out the code and push because we may not have it working at the end of the day. So okay, I guess I mistakenly refactored the wrong grep. Okay, yeah, that should be okay. The test cases should still pass now. If I can connect these out then. Okay, cool. Right. So in the test cases, what we need is, let's at least try to write a failing test if we can. So let's say we have this recursive function called whatever recursive grep. We pass a directory and a search string. How do we and we will need a channel is what we said, right?
yes.
So a channel of what? So
Line 131.
yeah, so
Can
so this channel. Okay, so it's a channel of map of string versus string array. I don't have a better name right now, but yeah, I can think of that name. So this is a channel For errors, let's maybe gloss over the fact about for now. For errors, we'll figure out how to handle them. And in this function, we are going to pass this channel.
Right.
And for now, I will skip the errors just for now, just to make some sense out of what is going on here. So recursive grep takes a directory and a search string and takes a channel where this function is going to write. So what will happen is in this function, we are going to write so we need to create a map. Yeah, we need to create a map here. So and it will always be, I guess, one size map.
No.
So what I'm thinking is this is how it will be, right? We will pass this map. Imagine we do the grepping here and whatnot, and we get that value. We will ultimately end up passing this map over here to the channel, right?
Okay.
And here, what we will do is we'll call this recursive grep and we will range over this channel. Now,
For at the
Actually, I just
oh, sorry.
thought of something.
Yeah.
By ranging over the channel, there's a thing where whatever we put into the channel that's not going to be sequential, right?
Correct. So what we are looking for is one file should be done in one go. That's why we have a slice of string as a return type here.
Yeah. Okay. Yeah. So that no matter
Correct. This
how the coroutine reads, all the inputs from one file, all the
Yes.
matches from one file will be in one map. Yeah.
Correct. So what we're saying is we will have one Goroutine per file.
Got it. Yeah.
That's the unit of computation as such. So one Goroutine per file means once the Goroutine finishes, it is going to put the entire file's data at once in a channel.
Hmm.
It won't be streaming in a very true streaming sense. Like every time there is a line match, it is not going to return us the result immediately.
Got it. Yeah. So it's gonna compute the entire file.
Correct. Yeah.
Got it.
That's So that's that.
This recursive grep is not a Go routine, right? I mean, we are not calling it in form of Go routine.
Correct. So I think this is a wrong probably name. This is like Go routine. So this is a function that is orchestrator for grep,
Yes.
recursive grep. It is not itself recursive function. So calling it recursive grep is kind of a misnomer and confuses. So I will call it. Yeah, I mean, how do we call it? Grep. For now, I can't think of any better name. So
Works fine, understandable.
yeah, so this is a actual orchestrator which is non-recursive.
Mm-hmm.
It is internally calling Go routines. It is going to internally spin up more Go routine functions and whatnot. So almost like it is going to do Go grep,
Yes.
right? And pass the reader here, whatever the reader, and the search string as it is. And it is going to also have to pass this channel here.
Yes.
I'm guessing, and this is a channel that this function will have to modify to be modified to accept a channel. And this is where instead of returning, appending match lines. After this, we'll just what are we going to do? We are going to append this plus the file name in a channel, like in a map. Create a map out of it and then put the map here on the channel. Yeah. So
Okay, what we can also do, see, grep orchestrator is just called once. From there, you are calling multiple Goroutines, but we were supposed, I mean, what we had discussed is we were going to call it inside walk.
correct. So this thing will be inside walk as an implementation. So in terms of implementation, this is how it will be. This is just a test code. So the implementation will be something like it is going to run do the directory walking. It is going to have this final like a single. This will probably be also inside this because for each file we have to create a map.
Right.
Yeah. So in that case, I think the map string, it can be like map directory and then array of string.
Yeah, so sorry, what I was trying to do here is that actually it might be better if we can write down a basic walk implementation and then build things accordingly. So this is almost like a so I'm trying to figure out how we can write the test case for it. Like, is there any way where we can conclude that okay, the test case will behave as this? That is what I'm trying to figure out. So here we have a channel that we pass, and in the assert again we'll have to make up some case. So we'll have to create like a say a directory and a very small minimalistic example based test where there is at least 2 or 3 directories, right, recursively, which where each directory contains either a file or an empty directory. So these are some of the test data cases that we will have to create. Right. So let me actually also write them down here. So, so what's a good place? So what are some of the things that we want to test, right? An empty directory.
Okay.
Like how what's the hit? So an empty directory that should be skipped. An empty file. I think that's understandable, but let's write that anyway. A directory containing one
Subdirectory.
subdirectory, yeah.
And a directory containing multiple subdirectories.
Correct. So this is almost like the array case, right? Where 0, 1, or many cases. So this is the 0 case for empty directory, 0 case for a file. I don't think this is needed. It can be part of a directory containing an empty file. Could be a test case because the top level thing will be a directory. So if I were to create containing,
Because empty file should be the test case for grep function, not.
so I think not for this. So we will ignore that because we've already covered that before. Makes sense.
Yes.
So if there is an empty reader, then it is not going to do anything. It will be an empty slice that we'll get back. So an empty directory is one case, 0 case. A directory containing a one single subdirectory is another case. And multiple subdirectory. Actually, one subdirectory means it's a subdirectory also containing a file.
Right.
Right. Or it can be something like this, directory containing one empty subdirectory. Does that make sense? So it's like nested empty directories. So this is a single empty directory. This is a nested empty directory. By empty directory, I mean it doesn't contain any file. So this is almost like we are testing the walk behavior as to how the walk works. Does the walk give us the subdirectory, or if it doesn't contain any file, what does it do?
Understood.
So we can ignore this if the walk behavior we understand as much. Like if we understand the walk behavior better, we can ignore this test case or the data creation. If not, then we create that one as well, just to be doubly sure. A directory containing one subdirectory and the subdirectory containing a file.
Okay.
And actually one here, what we can do is instead of writing it this way, it might just be better to actually create a structure of sorts, right? So let's say if I create test data, then this is going to contain like dir1, which is empty. Okay, so this is the dir1, or rather this is the dir1, and then I'm going to create, let's say, dir2, which contains dir3. So
Okay.
directory containing one empty subdirectory is dir2, right? And directory containing one subdirectory containing a file, this could be dir4 that we create, which contains file1.txt and dir5. So does it matter if it contains a directory or not? Maybe not. So
Doesn't matter.
it doesn't matter. So if you want, we can just get to this file2.txt just to be, I think this takes care of multiple cases and all the cases.
Right, right.
And if you want, we can also do like top level containing 2 files, and each directory containing multiple files. So file4.txt.
Each directory containing multiple directories. You can create a dir6 on the level of dir5.
Correct.
I
Okay.
think
Yeah.
that is handled with the dir 1, 2, and 4, right?
Oh yeah, yeah. This will be handled by dir1 to 4, right? At this test data level. So that we don't need.
Yeah, that's fine.
Yeah.
Yeah, I think what we should look for is a file at the dir 4 level.
Correct. Agree. So that also we have handled by dir4 level, this file, but we
Yeah.
can add it anyway. So we can add a file
Yeah.
0 for lack of better. So this is the file 0. So a top level containing both file directory. We have multiple files in this way. We have a single file actually also handled here. So we can potentially, if you want, we can delete this because again, recursively the behavior we are assuming is going to be same for file path.walk. Like it doesn't matter at what level you traverse, you will get the same behavior. Then in that case, we can also delete this file. What do you think?
Yes, makes
Because
sense.
if you use this directory, then that case is already handled. Like we have two files and one directory.
Yeah.
Yeah. So in the most minimal sense, this is the test case or test data directory that can help us. And what we want is we want the output to be in the order, in the sense that file 1 output should be all in one go, file 2, file 3, file 4. The order doesn't matter. Like we could get file 4 output first, no problem, but it can't be interleaved with file 1 or file 2 or any other file.
Yeah.
So this becomes our test data directory that we can create, and the test data will also have to ensure that we have some data that is matching across all, and we grep exactly using that to so as to simulate the case.
Right.
Okay. Interesting. Okay, I think we're already 1 hour over here. So what I'm tempted to do is stop at this point and let's do a bit more research on like filepath.walk. Maybe let's write our own uh, like dummy implementation and try out how this will work before really, because it's going to be trial and error. So it might be easier if we do the trial and error on our own to understand how walk works, which files are skipped, which are not, how do we pass the channel and go routines. Because I'm still not very sure on this kind of interface. This feels a bit too complex to me somehow. I'm not able to figure out a way to simplify this, but this kind of feels a bit too complex. So thinking of way in which we can simplify this as well. So as we will do the implementation, we'll probably figure out better ways to simplify things.
Right.
What I'll do is I'll comment this code and push it so that the test case at least pass and we don't have a broken code.
Line 120.
Yeah, this also. Yeah, so this is something that I'll commit, and in the next session we'll start small. So this is where that it is going to be hard for us to do proper TDD, because it's a huge jump, right? There is no easy way to break the component down into smaller bits for which we can write the test easily. So the top down in this case becomes much more difficult. So that's why we will most likely revert to a bottom top approach, where we have some function that is there. We will figure out the function signature as we go along and that means we also won't have a proper failing test case with a complete interface and whatnot. We might start implementation, we might experiment with it, how it works, what it does, what are the inputs that is needed, and then write the test case accordingly. And that's also fine, because yeah, this allows us to really explore the problem space a bit further. And the fact that because we started with test driven development, we were able to come up with challenges on like what all are the test data that we will need, how will we walk the file system, what parts should we parallelize or run in a Goroutine, things like that. So that we were able to figure out because we spend more time thinking about the problem itself. That's the good part. Okay, I'll commit this. It should be a good commit message. Is that okay? Does this make sense?
Yeah.
Yeah, not much not on comments, but that's what we did really. Okay, the next session, who's planning to drive? That's going to be critical hard. So I'd say if you can try out some sample approach and sample files, to try that, or sample code, do try it, and then we can do a session together.
Okay, sure.
Yeah, may not be this Thursday because it gives too less time to actually explore this, but if Mohit, yeah, if you want to give it a try, try the implementation, try the filepod.walk, and also with Suraj, I think. So both of you, if you get time to try this out, then one of you or both of you can present one at a time. Like we can, one next session we can be more around discussing what all we learned from filepod.walk, and other how will we actually make the orchestration work. And a session after that could be where we piece it all together and write a proper test case and the code and everything, and like we basically fuse things together and make it working end to end.
Yeah, makes sense.
Yeah.
All right, cool. Okay, thanks. See you next time.
Thank you. Bye.
Thank you.